All right, good evening and welcome. We are live recording for the August 20th ProfessionalVMware.com's vBrownbag. I'm Anthony Hook. I have Brandon Wilmot here helping me host this evening. Everybody wave to Brandon. Tonight we've got David Klee telling us everything we need to know about virtualizing Microsoft SQL Server. Tom, I have notes from the other week when I hosted. We have David here tonight. David Klee. Thanks for coming with us. What do you got in store for us?
Well, what we're going to do is talk through everything you all need to know to successfully virtualize even the biggest SQL servers and how to talk to the DBAs that manage them to help them understand that you can successfully virtualize this.
All right, cool. I know I'm interested. We deal a lot with that, and I'm sure I don't follow best practices on a lot of the ones that I've done. So that'll be good for me, too. Along with us tonight, the U.S. and the EMEA vBrownbags are off next week due to VMworld, but we will be streaming live audio from the Tech Talks, and if you're at VMworld, if you were there on Sunday, come by and check out the opening acts in the VM Underground Party. And last time I checked, tickets were still available. So if you're there, it'd be cool to see everybody. Let's see what else. Join in on the conversation during and after the show on Twitter using the vBrownbag hashtag. Ask your questions in the GoToMeeting question window. Was talking with David a little bit before. It's going to be kind of an interactive, so feel free to chime in with questions and you know, some good discussion on here. Everything will be posted online to our website. Also, there's an iTunes channel. I think it's a little bit behind. I haven't really checked it out because I'm not an iTunes user. So we'll still get that up and going. There's a bit.ly link for vBrownbag iTunes that you can visit. Pop your RSS feed reader in there, or pop that into your RSS feed reader and get updates. Otherwise, that's all that I have, and I'm going to pass this over to David here, and we'll get started.
Rock on. Thank you.
Thank you.
So I'm going to show my screen here. Okay, can you see my screen okay?
I can see it.
Awesome. Cool. Well, welcome, everybody. I have been a huge fan of the vBrownbags for a long time, and I'm very, very happy. This is the first time I'm presenting for one. So just a great end to a great week, actually. So this is SQL Server Virtualization for virtualization administrators. I do a lot of presentations for DBAs, but I've decided I'm going to add the complementary piece. So you, the VM admin, specifically in this case VMware, can really get to know what it takes to virtualize this and really see the virtualization process from the other side, from the DBA and from the app owner. And you know, we're going to help everybody meet in the middle so you can really successfully do those. Okay, what you're getting here, so I started my own company 1 year ago today. The primary focus of my company is SQL Server Virtualization Enablement. So what you're getting in this session is a lot of the tips and tricks and how-tos and gotchas that normally come as part of a project. So you're getting all this for free. So my name is David Klee. I'm a certifiable nerd. I'm fortunate enough. I'm a VMware vExpert and a Microsoft MVP. Just been a phenomenal couple of years. What you are seeing here is really all the tips and tricks that I go through all the time. I've got a home lab I heat my basement with so I can play around and test this stuff. So it's a lot of fun. So we'll get rolling. Okay. SQL Server is one of the biggest applications in your environment. It can drain the life out of a virtualization infrastructure. Why? What does it do? Why is it so darn heavy? And what can we actually do about it? That's what we're really going to focus on. So the agenda. We're going to talk about what SQL Server really is and really why it is that it does what it does with your infrastructure. We're going to talk about some things that you need to collect in terms of baseline and just ongoing performance collection that will really help you prove the points and understand where some of these bottlenecks really are. We're going to talk about really all of the challenges that I get when it comes to storage, host configuration, the VM itself, and then some things at the SQL Server. So some of these you may not be able to get direct access to, but you have what you'll have what you need to actually go to the DBA and say, hey, we're working on it from our end. Let's have you do some of these things and work on it from your end, and let's see what we can actually do. And then that leads into the end of this, which is really how to approach the DBA, how to see it from their perspective, and go forward and convey all of this stuff that they've never seen before in a way that they can comprehend and not only understand but embrace. Okay, so what is SQL Server? And this applies to really any big database management system, be it in memory or traditional in disk or both. It's a system that is designed to efficiently and effectively store data, retrieve it as needed, and do processing for things like reports, application data handling, anything like that. Now, all of these things can only really process data when it's in memory. So if you are constantly thrashing storage and you see memory just constantly being thrashed, you may not have enough memory because it has to be in memory for it to be able to actually use it. Now, any bottleneck, any inefficiency, any pain point anywhere in the stack can drive up storage consumption. It can drive up memory thrashing. It can drive up CPU ready time. All these things. I mean, lack of memory, misuse of memory, which is bad code, and bad code, and bad code, and bad code. Bad database and table design can really hurt. Storage latency really is painful. And then just paths to storage. So I've got a fun little story to start here. So about a little while back, I virtualized, or I had to come in and manage the virtualization of the biggest SQL Server I've ever seen. 64 virtual CPUs, terabyte of RAM, 1.3 petabytes of storage. Quote, it was running slow. How many of you have heard that before? So we did a little bit of digging and found out that it was SQL Server underneath SAP on VMware. And by running slow, this was a great big warehouse environment, and people would go to the order entry system, hit a button, out would print the next order pick ticket, and they would go out to the warehouse, pull it, come back, box it up, go get the next order. Well, on average, the application screen was taking 6.5 minutes to refresh. So that's somebody hitting the button and then standing there for 6.5 minutes. Now, about 10% of the time, it was hitting a 10-minute query timeout, so they'd have to sit there and start over. Brand new Cisco UCS environment. Brand new storage. What was going on? Well, they called SAP, and SAP, in their wisdom, said, you need faster storage. It's $1.7 million later. Didn't make any difference. They went and called up a bunch of different consulting groups. $230,000 in professional services later, wasn't any better. Well, I get wind of it. Somebody calls me up, and come to find out, that's what was going on. We get 2 days because the CIO is so ticked off at consultants. And what it was, you got a brand new, huge SAN, monster, blazing fast, brand new UCS environment, 8 gig network or 8 gig HBAs, 1 VM on the host. Slow. Fired up vCenter, hit the button inside the app. I/O went up to 379 megasecond. Flatlined. 10 minutes later, query timed out, went back. Okay, so this is 8 a.m. on a Monday morning. Start poking around. I go back to the server room, and sure enough, there's a 4 gig fiber switch in the middle. No active multipathing. 4 gig switch in an 8 gig path. So that night, we swapped out the fiber switch with an 8 gig fiber switch, installed PowerPath VE. Sure enough, I/O went up to 6.7 gigabytes per second. Query finished in 18 seconds. The morning, between 8 and 7 people run to the CIO's office asking what we did to fix it. And then I found out later that day there were a lot of ticked off people because they actually had to work. But it's one of those things. In that environment, they were ready to go back to physical. The VM admins were blaming SQL Server. The SQL Server guys were blaming the virtualization. Everybody was blaming the storage, and none of that had anything to do with it. So it's really taking this holistic approach and having everybody meet in the middle, and that's where we have the most fun. Okay, so we're all virtualization admins. What does virtualization really mean to a DBA? You got to remember, this is the DBA's approach. That's what they know about infrastructure. It's a black box. All they really see is they have their SQL Server instance with some connected databases, and they've got an application team that's sending a connection into this black box, and out it comes to the SQL Server. They route it properly into the database. Everything looks good. But the hard part there is they don't know what's in the middle there. That's where things get interesting. So you, as a virtualization admin, a lot of times, historically, virtualization is all about consolidation. It's all about maximum density. It's all about squeezing the most VMs onto the infrastructure that you've got. Well, with SQL Server and these other business-critical apps, the goal should be to design the stack for maximum application performance. A very close second is going to be consolidation ratios, but it shouldn't be the primary thing. Your goal as a VM admin is to identify any infrastructure bottleneck that's getting in the way within reason. Do everything you can to relieve that pain, so you shift that pain back onto really the data processing component, be it SQL Server or bad code is throttling up CPUs or things like that. That's where your mission really should be. Now, all of this has tremendous implications. So just virtualization alone, I mean, SQL Server now is licensed by the CPU core. Think about that. 40-core, 80-core machine. It gets really tough. So the goal here, you got to maintain the performance because, you can't take away performance from a business. They depend on it. What you can do is tune this thing right to get better consolidation ratios. And on average, the tuning that you can do with this is going to get you between 30 and 60% better consolidation while maintaining performance. Now, just one licensing example. I quoted out the SQL Server Virtualization Initiative just a couple of days ago. Without virtualization and in-place upgrade, the SQL Server license was $650,000. If you were to virtualize it, including the cost of the hardware and the VMware licenses and the SQL Server licenses, it went down to $210,000. That's substantial. So I joke with folks, SQL Server licensing really does take everything about VMware and a virtual infrastructure and turns it into an overall rounding error, especially the bigger you get. But the bigger you get, the more of an impact you can make with licensing. Now, dumb thing for anybody here that manages this already, if you have SQL Server licensed for SQL Server 2012 and above, and you're licensing Enterprise Edition with the core, physical cores licensed, if you have hyperthreading turned on, they count those cores. From a physical machine, they don't. But when you virtualize this stuff, if you're licensing the physical cores, it counts. So turn hyperthreading off unless you want to pay double for the license. Okay. So traditional systems, physical machine connects to get to it, virtualization, OS, instance DB app, networking. You as a VM admin generally want to start with a bottom-up approach. These are the areas where you can have the most impact. The database, the instance, the application, a lot of times we don't want to go there. But from a VM standpoint, this is where you can do the most good. And that's really great because I would say over 80% of the problems that I have with a virtual SQL server start at storage. It's crazy the amount of storage problems that I've seen out there. Where can we go from here? The biggest piece here is getting some objective performance metrics. So not only can you say, yeah, we're doing better, in whatever thing you're trying to make faster, but you have some objective numbers to actually demonstrate it. And it can be in the form of min, average, max over a period of time, just as long as you have all selected. So I tell every DBA, they're doing any kind of performance project, performance metrics to show before and after, you have to have it. Otherwise, people call you liars, they don't believe you, or you may accidentally make something worse and you have no way to really demonstrate and roll back. So to me, this is the biggest part of virtualizing this. So whatever you can use to collect all this stuff. So I mean, VMware vCenter stats, host level stats, really anything with the infrastructure. So path contention, path utilization, CPU, memory, storage by IOPS, by LUN, whatever you can get, ongoing collection of that will make or break this environment. And it's fun because it's not just here. You have to start overlaying this stuff, and I'll show you some examples of that. Okay, so storage, again, like I said, #1 source of issues. I tell everybody you have to design the storage for performance and then capacity. Again, SQL Server is meant to store and retrieve data off of a storage device somehow. And some of these volumes of data, you know, anywhere from tens of gigs to just petabytes of storage, and it has to be able to retrieve that quickly. So no matter what, you got to tune for IOPS. Latency will kill you. Generally, I don't care as much about raw throughput because I mean we're not pushing 800 gigabyte per second. We're pushing tens of thousands of little tiny 8K chunks all over the place. I've had really good luck with flash hybrid arrays lately. You know, it's a way to kind of offload a lot of these IOPS requirements without breaking the bank. Now, all of these things, they're at an infrastructure layer, but your DBA can measure inside SQL Server latency per SQL Server data and log file. So they see the end result of every piece of this system stack all the way up, and anything above 25 milliseconds latency is rough. 25 is my yellow line, 40 millisecond and above sustained is kind of my red line. That's where SQL Server really starts to feel it. And it's not, you know, a 1 or 2% performance hit. It's more like 10 or 30% performance hit. It really adds up depending on the workload. Now, we'll start to get into some of the recommendations here. And again, you know, take all these with a grain of salt. You know, every workload is different, but these are all my starting points. I use the Paravirtual driver for everything that is SQL Server related. So basically anything not DOS. I will spread out, you know, all the way up to 3 PV-SCSI controllers. I usually leave the C drive on the LSI SAS driver, just because I want that driver native to the OS. But again, you know, 10 to 12 performance improvement on that for free. It's great. I use it all over the place. Virtual disks. This is one of those. It's one of the big questions. It's why do I need to split out my database objects if I have the same set of disks on the SAN? If it's just multiple virtual LUNs all from the same set of disks, and the answer is you still need to do it. I always split up database data, logs, TempDB, and the operating system at a minimum. You know, a lot of times I usually go beyond that because you've got different disk queues within Windows. You've got multipathing inside VMware. You've got different paths to get to the storage, and you've got different controllers that you can connect to. It does make a difference, and every little bit adds up. You know, and some of these may be small, but you know, 2% here, 4% there, 10% there, and eventually you've got a greater consolidation and performance. Everybody wins.
So just to elaborate a little bit, so data store presentation by workload type, you're suggesting an actual, like a separate data store, a separate LUN on the back end for database data, a separate data store for logs for the temp and for the OS?
Yeah, I am. And potentially not just one, but sometimes a lot depending on the workload. Because, you know, let's go down the list here. Database data is generally 8K or 64K chunks that are extremely random. They're all over the place. Logs are generally 8K sequential writes. It's rare to actually, you know, comparatively, it's rare to actually have any real amount of read there. TempDB it's this dumping ground where SQL Server does work for sorts, for order bys, for large joins, or for temporary objects inside long-running stored procedures. The nature of TempDB is just crazy. So even if you've got logs and TempDB in the same LUN, well, the combination of the two will make that very random. So I like to group similar workloads onto different LUNs, and the controllers, you can optimize and tune this stuff and get a little bit better performance.
All right.
Did that answer the question there?
Yeah, I think so. Another question that came through was, and it's kind of what you talked about, I think, a slide before. If you can get metrics on a good physical implementation of SQL, and you compare that to a virtual implementation, you can compare, the metrics. But how do you, but how can you get metrics on a bad virtualized SQL and then work on improving it? And I think that some of the things that you're talking about now, changes that you can make to the environment, separate out your data stores.
Yeah, exactly. Exactly. Yeah, there's so many metrics that you can get. I mean, anything from, let's say I want an 8 a.m. to 5 p.m. Disk latency collection off of all my SQL Server data objects. And let's say I run it for a week and get, per hour, this is my average latency. And then I go and implement the paravirtual driver and do a storage vmotion and move some of these things to their own LUN, and then watch it again for another week. And you can start to see what are these latencies doing over the course before and after. And usually it's an incremental improvement.
Another question that came through is, it says, by the time it all hits the SAN, hasn't it been through the I/O blender and all access is totally random? So I think that's a question against separate data stores. And another question that might be similar, does splitting up the VMDKs on different data stores apply when you're running tierless or hybrid storage?
Those are really good questions. Splitting them up,
feel free to separate those questions too.
Yeah, the first question there was, the I/O blender by the time it gets to the storage. Usually that's accurate, but if you can split these things where they've got their own distinct path, it does get a little better. Again, it's not a huge improvement, but let's say I'm virtualizing 1,000 SQL servers. The little improvements get magnified all the way up. Now, tiered and hybrid storage, that's the fun one. A lot of this stuff either starts to apply less or just doesn't apply. Now, an all-flash array, I would say, doesn't apply nearly as much. Again, I want to see more metrics and research done there to prove that, but in my experience, I have seen less of that. Now, usually what I'll still do eager zero dick provision disks just to get away from the zero write penalty on that. But a lot of times, if it's a hybrid array, I'll thick provision it, but I'm a little less concerned at the SAN end. I'm still worried about disk queuing inside Windows, though, because Windows can stack up as well. The more paths you have inside Windows, the more that those queues can spread out.
Cool. Thank you for that.
Those answer those questions, okay?
I think so. As far as my understanding, and they haven't followed up on it yet. Another question somebody said, I'm a DBA who snuck in here. Just had an admin tell me there's no point in breaking them out while running through vSphere, because the system will do what it pleases with it.
Nope. My contact info will be at the end. Have the guy call me. I'll talk a little bit of sense into him. There are queues in every step of the stack, and I've had Windows disk queues stack way up, and we just split out a handful of things to multiple virtual disks. We even had them on the same data store, and we got better performance. It's pretty fun. Okay, are there any other questions so far?
Not yet. That looks like it.
Oops, you still there? Whoops, you still there? The audio just went quiet.
Oh, hey, can you hear me now?
I can hear you now. Cool.
Okay, cool. Yeah, no, I'm sorry about that. Yeah, no more. Nobody else followed up with those, so I think we're all right.
Cool. Okay, so now with storage testing, I want you to prove it to me. Here's the fun part. There's a free utility from Microsoft called SQL.io. Now, it's got SQL in the name, but that's because it was written by the SQL Server team, not that it really has anything to do with SQL Server. It's free. You can download it. Now, there's another PowerShell script by Niels Grove Rasmussen at that link there. I use these in tandem all over the place because what it does is you pick inside Windows, pick a virtual disk or a set of virtual disks and say, I want to test this virtual disk on an increasingly heavy load intensity, and I want to do combinations of sequential read or random write, whatever the combination is you want, all the way up to just really, really, really high numbers of these different permutations, and it'll go and execute that sequentially and put all of this to an output. You can go graph that. He's also got another thing in there that will actually extract the data out of this really huge text file and put it into a CSV format for you. All you got to do is graph it by thread intensity, group it by the test type, and you can start to build a curve of what your storage is actually doing. Cool thing is this thing can actually do multiple drives at the exact same time, so you can simulate anything you want. And if you determine through, just perfmon profiling what your average load is throughout the normal business day, you can tune this thing to be tailored to your SQL Server workload. For example, if I want to do 64K block size, a random read throughout the course of the day, you can use this to go get about where you're at, and I use that to go test across the board. So now, this is a test that I ran on the customer site a couple months ago. Why did sequential write drop off? It's one of those things. The customer called me because they were doing SQL Server backups to a single virtual machine, and they had like 80 SQL servers that they were backing up. Well, what they noticed was over 6 months, the backups in mass were taking longer and longer and longer, and they were starting to get close to the end of their maintenance window. We went in and looked at it, and what we found was through this one picture, we were able to go profile the SAN, and we found out that sequential write was coming in so fast that at some certain point we actually hit the tipping point in the SAN controller cache, and it was having to suspend I/O for longer and longer to actually flush a little bit of data out to disk. And with that, they went in and we staggered the SQL Server backups, and they went and got more SAN cache, and everything was fine after that. But stuff you would never, ever really see unless you went through this really quick test to go prove it to yourself. What's the storage from the VM standpoint? What can you actually do? Cool thing about SQL.io, it gives you latency in milliseconds, and it gives you a latency histogram. So you can see, let's say 60% of my I/O happens in less than 10 milliseconds. But I've got another 10% that's happening at an average of way above a threshold. That's pretty substantial. And best of all, it's free. I love this tool. Any questions on SQL.io?
David, we did have a question that came through about SQL on vSAN.
Mm-hmm.
What's your experience with using SQL on vSAN?
I have not done it very much because in their documentation they state that vSAN, and this is nothing against vSAN, the documentation states ideal for Tier 1 or Tier 2 and Tier 3 workloads. I've done some evaluation with it, but right now I'm watching it. I want to see more in play before I go and put heavy loads on there. That's not to say it's not going to be able to handle it. I just want to see it first. Okay. Any other questions?
Not yet, no.
Okay. Okay, so there's stuff that you can do here from an infrastructure standpoint that can really improve the storage performance. Some of these are pretty obvious, replace the SAN. But some of these are a little less obvious. So I mentioned before, SQL Server has to read from disk and put data in memory before it can access it. So what's the best way to reduce I/O? Add more memory, to a point. So more memory gives you essentially more read cache from within SQL Server, which usually contributes to less read I/O. So there's that. There's more interconnects, faster interconnects, If your storage vendor has third-party multipathing software, like PowerPath, any of the EqualLogic stuff, anything like that that has a good third-party multipathing software, buy it, install it, use it. It's going to work. The default round-robin path policy is good enough some of the times, but it's not going to give you active multipathing. Now, there's some work you can do with LinkAg. I've done some experimentation by actually forcing a pathing policy to do round-robin multipathing IOPS equals 1 or 0. I don't want to say do that in production unless you do a lot of testing, but it's stuff I have done to improve performance there. The other thing, every single SAN vendor out there has a SAN configuration guide for SQL Server. That still applies when it's virtualized. So guides, look to see what they recommend the HBA QDEP settings are. Go look at that on the HBAs on the physical machines. That you're running a good HBA QDEP across the board. Now, so to go back to the flash topic from earlier, times what I'll see is some inconsistencies with disk, from inside the VM, disk block size alignment. So Microsoft recommends a 64K NTFS block size for anything that's not the OS inside SQL Server. Generally respect that and follow it. What I found, though, is that some of the flash SAN vendors, whereas a regular SAN may not be too sensitive to either 4K or 64K, some of the flash vendors are a little more sensitive. So a couple of them, I've actually gone through and I've changed the stripe size inside the LUNs presented on an all-flash or a flash hybrid array from either 4 or 32K up to 64, and I can get a little bit better performance out of it. So just keep that in mind. Check to see what's there. You can actually use vSCSI stats to go look to see the average block size that the SQL Server is putting on the SAN, and you can actually go tailor those settings. So there's some obvious stuff. Fast array configuration, replace the array. One of the things that I've done is SSD caching, and I talk about this a little bit later, but that's the big thing. You can have fun with that. I'll talk about that in a little bit. One of the other things, so I talked about spreading out the workloads before. Now I'll show you what we mean here. So inside, from a DBA perspective, this is what they've got to work with. You got Windows. You got the SQL Server instance. I've got the buffer pool. That's your memory cache. Got the app coming in to talk, and it needs to go to a database. There's a lot of different layers in there. So you can actually file group, which is a group of data files where I can logically go in and put certain database tables or just stuff like that. Now you can split that out, you can spread it up. This is one of those ways where when people have a through and split this into multiple files and multiple data files, and you can actually get more granular than that with the partitions, and actually split out old archival data into a different VMDK and put that on slower storage if I want to save fast storage for my hotspots. In addition to all that, you've got your transaction log. The transaction log is one of those things. It is vitally important, and I've heard it more than not. Sometimes people think that the database transaction log is kind of like an error log, and it's safe to delete or clear out, and that's a really, really big no-no. You have to have that to maintain data integrity. Your backups and restoration process depend on that. And they can get big. That's kind of the scary part there. So you can split out and spread out all of these workloads to try to balance like workloads the same. You can move archival data to a second or third tier of storage. All this stuff, if you plan up front, you can have a bunch of different virtual disks in here, and now you as the VM admin are free to storage vMotion this stuff wherever you need, and life gets better. Are there any questions so far?
Yeah, there was a question back on memory. You said, obviously throw memory at it if you can. It was, can you only add memory up to 128 gigs with 2014 standard? And a follow-up to that, and is that 128 gigs for the block cache or the whole Windows server or what? Question mark.
Good question. So with SQL Server 2015 Standard Edition, I do believe is limited to 128 pool memory. I need to double check that though. I think that's accurate. I know 2012 was 64 gigs. But that is SQL Server EXE and most of the SQL Server objects plus the memory pool. Older versions of SQL Server like 2008 R2 and before, a lot of those external things were external to that figure. Now that's per instance. You can in fact install multiple instances per OS. So that is, it is a limitation of Standard Edition, but that's one that if you really need above 128 gigs on a SQL Server, there's a good chance you're in a position to buy Enterprise Edition. Then you go up to the Windows Max, which is some ridiculous number. Was there another part of that question that I just missed?
No, that was. I think that was it. I don't see a follow-up to that one.
Okay, cool. Good question.
We also have a question about how do you deal with active arrays where you have to use fixed path as the only option?
Well, if I'm forced to use fixed path, I'm okay with that. But what I will do is I will balance the workload accordingly so that I am trying to actively use all of those paths. For example, in this icon, in the screen right here, let's say I've got a really heavy application that is commonly joining, let's say, 2 tables for major reporting operations. Well, what I'll do is I'll split that out where one of those tables will be in one file group. Another one of those tables will be in another file group. I'll park each one of these file groups on different virtual disks, and from a storage side, I'll put those on 2 different LUNs. And now I know because they're commonly being joined, it's going to actively go down each one of those paths at the same time to facilitate that join, and that way you can get a little bit better aggregate throughput. Good questions.
Another one came in. Let's see. Is there a benefit to using memory reservations if you're not over-allocating memory within your vSphere host or cluster, as long as you're mindful of new VMs and increasing memory usage? Aside from, like, I would say, like the vSwap file. What's your take on that?
Man, these are good questions. This is awesome. So the memory reservation inside SQL Server basically means that SQL Server cannot use more memory than some certain amount for the buffer pool and the related objects. I do always set that inside SQL Server. Always, 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 I always set that. What I love to do is I love to balance. I make sure that Windows has enough headroom in order to be able to perform things like system-level backups and routine antivirus scans and Windows updates and all the usual stuff that gets in the way. If I don't set that, SQL Server, well, you all know, SQL Server has the right to go in and try to consume every bit of RAM on that machine. And sometimes you can get into a state where Windows needs more, and SQL Server is going to try to hold on to everything. If it doesn't have enough headroom there, you can potentially get Windows instability where they start fighting. What I love to do is I make sure that I've got an amount of headroom there, and that's where the performance profiling comes in. So to make sure you have enough OS headroom in there. Now, one of the benefits of setting lock pages in memory and that max reservation is that lock pages in memory is something that says, okay, you can't give up this memory to Windows. In SQL Server 2014, when you do that, it'll actually change the way it uses the memory pointers inside Windows. So SQL Server can actually go and use, I believe it's 2 meg memory segments instead of 4K. Gets a lot more efficient, especially when you're managing, let's say, a 1/4 terabyte of 4K pointers versus 2 meg pointers. So just by enabling that one session, which you have to have the max memory reservation there for, I've gotten, what was the metric? I think it was like 17% performance improvement on a SQL Server just by flipping one switch. It's pretty substantial. So long-winded answer there, but yeah, I do go through and I set that all over the place.
And does that include memory reservations within vSphere? I mean, per VM, you can set a reservation. Does that count, do anything, hinder, or help?
I cover that in a little bit later, but I'll touch on it now. For production SQL servers, I always set memory reservations for the VM. One, it gets rid of that, or it knocks down to a 0-byte vSwap file, which on some of these VMs can save you, hundreds of gigs. Two, memory pressure inside SQL Server is one of the bigger silent performance killers. So if SQL Server has to have everything in memory in order to be able to use it, and what it thinks is in memory is actually on disk, well, that's many, many, many times order of magnitude slower. And even 2 or 3 gigs worth of paging inside Windows can translate to upwards of a 50% performance improvement hit to that SQL Server. It's really substantial. And that's at the point where the CIO's in the DBA's office with a baseball bat saying, fix it right now, and everybody's scrambling to figure out what's going on. Gets interesting. Cool. Any other questions so far?
No, you're all clear from this end.
Sweet. Okay. One of the other things that I love to go test is network throughput. It sounds kind of arbitrary when you're talking SQL Server, but think about it. All the applications have to connect to SQL Server through the network. I kid you not, in the last 2 weeks I've run across 5 different issues all related to virtual networking. Most of them are around VLAN traversal, where we were getting really good performance if they were on the same port group, but you put them on different port groups and it has to go back to the core switch, and the overhead was just horrible. There's a little utility that I love called iPerf. There's a newer version here called iPerf 3. You can download it at the link on the screen, and there's a how-to guide on my site, but basically it's 2 commands, simple executable. iPerf -s gives you the listener. iPerf -c, destination name, -t, and then a time in seconds. And what it does is a one-way, you can opt for a two-way, network throughput performance test. Awesome. Real quick way to validate end-to-end performance. And you can see in my home lab here, 943 megabit per second is pretty darn close to theoretic on a gig switch. Now, what happens, actually, we'll go this from a different angle. You want to be a hero to your environment without them having to change a single line of code. Go ask the DBA if they do a lot of data consuming every evening, like importing data from a lot of different sources, things like that. What happens if you put those 2 machines, those 2 VMs, on the same port group and then put them on the same physical machine? This one stumps almost all the DBAs, but the VM admins, you guys will get this. You know that if it's on the same port group, it doesn't get out to the physical network. It stays in the backplane. So what if the 2 VMs, the data consumer and the data source, are on the same physical machine, on that same port group? I've taken nightly data load processes and shaved off 70% of the runtime without changing a single piece of code. You can set up DRS affinity rules to go enforce this. I mean, anything. Nightly data loads, application servers, database backups, even just the application server. If it's a really heavy consumer of data, park it on the same physical machine. It's huge. It's huge. Makes a big difference. And you can see just right there, just a real simple test on a 1 gig network, 15 times performance improvement. Cool. Any questions so far?
Actually, we did have a couple trickle in before about what about using memory shares versus reservations when you're setting up your RAM for your environment? As far as on a per VM, I think on a per VM basis is what they're talking about.
Yeah, to me, I generally stay away a little more from shares than I do more resource pools, mainly because just administrative overhead. You have to go monitor and balance, and it's time consuming, especially if you're dealing with a lot of different systems. If you've got the capacity to go handle those, by all means use whatever works. It's a good way to go do that. But I generally go and do a little more high level with that. I'll usually separate them out into resource pools like production business critical versus production non-critical versus pre-prod, and just kind of tier those.
That makes sense. There's some other networking questions that are coming through too. One of them says, I presume large packets won't help much on the SQL send as far as data on the network?
If you've got everything end-to-end configured properly, it will make a performance improvement, but it's really subjective into how much data the application server is actually consuming. A lot of times I've found that it's just not worth the administrative overhead unless the application server is really, really data hungry and just pumping loads of data across the wire. If it is, by all means, go through the effort to go validate and test and make sure that you will get a noticeable performance improvement on it. But that's one of those, 5% or less actually needs that.
Sure, and you're talking jumbo frames end to end.
And that's application to SQL Server.
With a little bit of lag.
Yeah, basically jumbo frames between the app server and the SQL Server, and not the SQL Server to IP-based storage. I'll clarify that.
Okay.
And we also have a question, is the performance testing that you're showing here, is that using the VMXNet 3 driver or E1000?
I use VMXNet 3 for everything. See, I've generally found it to be more stable and a little bit better performing than all the alternatives. Yeah, good questions. This is fun. Okay. Any other questions before I move on to the host?
Nothing that's rolled through here yet.
Okay. Okay, in bright red, and I wanted to use gratuitous use of link tags. If you have a dedicated environment for SQL Server, virtualized, 0 memory over commitment, please. It is a big, big, big deal for a SQL Server when you start swapping. Start ballooning. It gets bad. It gets really bad. So, in full memory reservation, I love the dedicated environments, but a lot of people they don't have the kind of scale that would necessitate that. So at a minimum, top-tier resource pool, full memory reservation, no memory pressure to that VM at all. Now, at the host, I always say fastest possible cores and not necessarily the most cores, because everybody thinks that all these database platforms parallelize everything and you're using all the CPUs equally. Well, it's not necessarily the case. A lot of queries, a lot of different tasks inside these systems are not parallelized. So if I'm depending on parallelizing, or let's say I bought a 12-core CPU instead of a faster per core, but only 8-core CPU, a lot of times I will actually opt for the 8-core CPU, where I can have every single thread perform maybe 20% faster, because that 20% can mean the difference between making a nightly maintenance window or not. It's pretty scary. Now, the other thing here is, if you've got any kind of big SQL servers virtualized, max out the host memory capacity within reason. You're going to run out of RAM well before you run the CPU. And again, more memory in the VMs, more memory in the host, less I/O in the storage, and you can take the storage that you have and make it stretch longer. And it's not just more memory, it's the fastest memory combination as well. I mean, there's some pieces of hardware out there where if you populate every memory slot and basically fill up all the DIMM nodes, you will actually declock the RAM by up to 25 or 30%, because there's some limitation in the machine where if you pull out that last slot in each DIMM node, everything gets goes back up to normal speed. Just check the physical machine configuration and you'll see that. I mentioned it before, full memory reservation for all of your business critical SQL servers. It's it really is a big deal, especially if you've got a lot of stuff that you're working on. Okay, the stuff that I care about in terms of metrics to really start monitoring, collecting, so outside of the normal CPU consumption by core or memory consumption per host, stuff I care about, if you are ballooning at all and those SQL servers are impacted, that's a big deal. How many people here actively monitor vCPU ready times at the VM level? Don't know can we do a poll on here? I'm really curious to see.
Yeah, I think so. I haven't done that. Let me see what I can do with that. Single choice answer. Let's see. I'm getting some people are commenting in the questions. Yes, we do. I monitor vCPU ready times. ESX top! Exclamation point.
Excellent.
Do you actively? I know I do. With a lot of different environments that I deal with, a lot of some business critical apps, some hosted applications, a lot of VDI stuff. That's something I watch. Somebody says we use vCops to monitor ready times as well.
Perfect. Yeah, I mean, the biggest thing for me, I set, they feel arbitrarily low, but they're really not. I generally like to say that if you have a CPU ready time per vCPU per VM at 500 millisecond or more, or really 2.5% inside vCops, that is my unofficial red line for a virtualized SQL server. And again, that's per vCPU. Because that's right around the point where performance of that VM, of that SQL server, starts to get impacted to the point where an end user might notice. So I will generally inside, vCops or whatever monitoring tool you've got, I will actually go put an active alert at 400 sustained for more than 5 minutes. And that way I'll get notified if you start to see this, because then you can at least try to be a little proactive with that. And if you get a lot of this stuff, maybe write or offload some stuff, pin them to other machines, things like that. You can just start to reduce the resource queue contention and make things better. And I also monitor data store latency, because again, SQL Server. Or go ahead.
Oh, I'm laggy by I think 5 seconds here. I'm not trying to interrupt you. I was just going to say, I did make a poll on the poll side. So if you select that poll and launch it and save your answer, somehow we can get to the answers. I'll have to figure that out too. I haven't done that before. And then I was just going to ask if you could explain CPU ready time to anybody that may not be familiar. Maybe we got some DBA admins in here that aren't familiar with what we're talking about.
Absolutely. So I pulled up the FAT client. Yeah, I know it's still a FAT client. Okay, what vCPU ready time is. So in my eyes, things are real black and white in my eyes. So this is my home lab, by the way. Everything that I see inside a virtualized environment is essentially resources, compute resources, so CPU, memory, network disk, and queues to get to it. All VMs are things that submit tasks in queues to go grab resources. So if you have a queue and you have a lot of things pumping stuff into the queue, what do you get? You inherently get time spent in that queue. This goes for anything in a virtual environment, anything that a VM can grab. CPU time, disk access, all of this stuff. So what do you want to do? Let's say I have a lot going on in my CPUs on a physical machine. If it gets stuck in that queue for a long period of time, that is performance essentially gone from that VM. And you don't ever see that in an event log. You don't see that in any kind of in-app monitoring tool. If you're at the VM level and up, you can go see it through vCops or Center Client, things like that. But now I'll show you here. I'll just pick one of my database servers to get to it. Now VMware measures this in milliseconds spent per polling interval, per vCPU, per VM. That polling interval is 20 seconds. It's measured in milliseconds. So if you pick chart options, get rid of all the counters, scroll to ready, hit OK. I can go see here, this VM has 4 CPUs, and I have a cumulative. I will look at the individual CPUs. So here, CPU ready time per that 20-second polling interval, 19 milliseconds, 55, 39, 44. That's 19 milliseconds technically divided into 20,000 milliseconds. So let's go with the big one, 58. That is a 0.29% performance penalty. That's very acceptable for a production server. That's about as low as it's going to get, really. But now what happens is, if these start to drag on, these numbers are going to creep up. So that 500 that I was talking about would be at the vCPU levels, 500 milliseconds gone in that polling interval. Now again, it's technically only 2.5%, but SQL Server is so CPU latency sensitive in a lot of the things that it does that if you have a heavy SQL Server that's pretty active, a 2.5% performance penalty here per vCPU could actually translate to a 10 or 15% performance hit inside the SQL Server. And all the DBA knows is that end users are calling and complaining, and they have no way to see this from inside the VM. So it's another long-winded answer to the CPU ready time, but that is one of the biggest performance killers right there that is silent, because they can't see that from inside the VM, where they can see storage latency or network latency, things like that. All they know is stuff is just slower. In an environment with a lot of wrong-sized CPU inside VMs, or just a lot going on in the host, these numbers are going to be extraordinarily high. I've actually seen a cumulative CPU ready time of over 240,000. Customer didn't really like it when I held up my cell phone and said, I got a faster SQL Server for you.
So a couple things. I just want to apologize.
Do we have any other questions come in?
Playing with the poll button, and I think I ended it on accident. But looks like 67% said yes, they do monitor it. 33% said no, and nobody said what?
Good.
Mark?
Good, 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 good.
The other thing that I wanted to share too is one thing. I've seen. You mentioned CPU ready times, and I had a host that just overloaded CPUs on their box, and they actually only had a box with or a host with 8 cores, and they made a bunch of 4-core VMs.
Ooh.
So, those VMs are waiting for 4 cores to be open at the same time. Well, they're wondering why their actual clock started to run in slow motion on those VMs, and I had to explain, they are literally running in slow motion, waiting to talk to your processor. They couldn't see it in Windows Performance Monitor. They couldn't see it was being used, but everything was just slow. So I had to explain to him, that's what you did. Don't do that.
It is scary, the amount of problems that you can have, and it's not just SQL Server. I mean, Oracle, SharePoint, SAP, major Java apps, any of these things, they're just really sensitive to that kind of stuff, and that's the kind of stuff you got to watch, because they will squawk and scream because they don't have the ability to see those raw numbers on that screen.
Yeah, and somebody had a question about your lab.
Stepping back.
Oh, go ahead. I'm sorry, Brandon. Yeah. What was that?
No, I was just going to go back to some SQL licensing. We had a question about that. Someone wanted to know if you had a 4-core SQL license, would you give the VM 6 cores and then restrict SQL to 4 so that the other 2 can be used for the operating system?
I would answer that question with another question, and that's what's going on in the OS that would need 2 CPUs? If you have a legitimate reason for that, yeah, but for the licensing sake, if you can audit, if you've got really strict change control and you can audit that setting is enabled, you're probably okay. But it's rare for me to want to monkey with CPU affinity inside SQL Server to go set that.
Sounds good. And one other question was about your lab. They said those SQL Server 2012 templates, do you include SQL pre-installed on your templates for a home lab, or do you run a script after the VM to install that?
That's a really good question. You can see all of them down here. I actually pre-install and configure everything. I do not join them to the domain prior to template deployment. And if you, how much can I say? If you watch my home blog in October, I'm actually going to have a lot of stuff that you'll be interested in with that. But yeah, I will pre-install it because I'm not joining it to the domain. And all you have to do inside SQL Server is do a command called sp-drop server, and you remove the old server name, and you do an sp-add server, and you basically take the new machine name, add it in a SQL Server, done, and then join everything to the domain, and then life is good. Otherwise, you'll get weird Kerberos errors, and it's just not. Cool. Other questions?
I think that's it.
Sweet. A lot of fun, man. It's going to run a little bit longer because there's a lot left, but you know, I'll stay here as long as you guys want because this is fun for me. Okay. So I talked about all the different types of path contention, data store latencies, all this stuff. Monitor, track, record, baseline, and trend, anything and everything you've got. And VCOps is a great way to do it. We're going to talk a little bit later about what you need to get from inside the SQL Server and how to overlay this stuff as well. Okay, so I mentioned noisy neighbor here, but we already talked about CPU ready time. You know, stuff like this can contribute to really bad CPU ready time. End of story. Okay, this is why I say overlay anything and everything that you get, because what you've got here is a it's a memory active chart inside VMware. This was me doing a data load of about 25 gigs of data in my home lab one night, and you can see the active memory went way up. And then I was working and crunching a lot of numbers, and I looked over, and I just happened to have the screen up, and I noticed the bell curve instead of a flat line. This SQL Server database was actively being used while I was running all these queries. I mean, it was like 3 or 4 queries a minute for a couple of hours. The active counter dropped back down to almost nothing. I've had some VM admins come to me and say, you're not actively using all this memory in the SQL Server. We want to reclaim some of the RAM. Well, it doesn't quite work like that because remember, SQL Server holds on to memory to use as a read cache. The only time memory changes is if once the memory blocks are full, the only time it changes is if something is kicked out of RAM to make room for something else. That's the active memory down here. But anything that's active from a SQL Server standpoint means it can be read from. So from SQL Server, this is a flat line way up here. VMware showed it as not being active anymore. So you can't take any one metric and base an action on just one metric. You got to look at everything. So I joke that, you know, all these counters lie because it's from their own perspective, but a lot of these are not app aware or app, you know, sensitive to this stuff. It's really interesting watching the intersection of these technologies. Okay, any questions before I move into the VM itself?
Actually, yeah, just as you asked that, we had one come in. And Brandon had to drop off. He had some other commitments, so hopefully I can land this plane safely.
Cool.
Somebody asked, is there a good sizing tool for how much memory to allocate to a virtualized SQL server?
That is the magic question right there. Unfortunately, I don't know of one. Now, I am a huge fan of a utility called, it's by a company called SQL Sentry. It's called a Performance Advisor. I'm a huge fan of that tool. It goes through and will tell you if you're under memory pressure. Now, it does not go through and tell you what it should be. Now, I'll let a cat out of the bag here. I'm giving a presentation at the SQL Pass Summit the first week of November. And my goal, and I really hope I can stick to it, is to release a PowerShell script that will collect data around the clock for whatever time period you want. It'll dump all the stuff to an XML file, and it's just Windows, counters, SQL. It's virtualized, you point it at the center, and it'll go collect the stats from the VM. And my goal is to create an XML file that you can sort through and make sure it's okay to send. Upload it to my website, and I'll have an algorithm there that will spit out a VM right-sizing recommendation for you, including the counts of memory. So that is my goal. I hope I can accomplish that. I'll at least have a beta up by then. So I want that out. I want that in the public domain, and I'm going to give it away.
So somebody has to get into 128 gigs plus whatever the OS needs for memory?
Sorry, can you repeat the 128 there?
Yeah, it just
or
says...
What was the 128 from?
It just says 128 gigs plus whatever the OS needs. Maybe the asker can elaborate a little bit. Give me just a sec. We'll come back to that. Go ahead and
okay.
Come back to that question.
So we've talked about storage, host, things like that. We're going to talk about the VM itself. So for me, I generally love to make the VMs themselves very, very flexible. Now again, this is very sensitive to licensing. It's one of those double-edged swords. I hate to be the messenger with a lot of this, but in an ideal, perfect world, I do say one SQL Server instance per VM. Now, it's not one database or one app. It's one instance. And I don't like to pile a lot of stuff on one instance. Like a lot of folks, to save on licensing, in the physical world, they'll build a monster physical machine and put 8 or 10 physical SQL Server instances on there and then pile in hundreds of databases for hundreds of apps. And then how do you patch that? You have to coordinate with how many end users to go coordinate a 30-minute window on a Sunday evening at 2 a.m.? It doesn't work very well. So again, a perfect world, one instance per VM. I generally would like to see it as one or just a handful of business purposes or roles. So it would be more smaller VMs instead of less bigger VMs. Not every environment's going to work well like that. Licensing, huge concern, of course, but that's my perfect world there. At the VM itself, there's a handful of things that I do that a lot of folks don't really think of. I've been running EFI BIOS now for a little while, and I've had really good success with it. vSphere 5.5 now has a drop-down inside the advanced configuration of a VM. You can go set the latency sensitivity for CPUs. I will generally set that to high for SQL servers in production. The other thing is vNUMA. Even though you may configure, let's say, a 2 virtual socket by 2 virtual core VM, it doesn't OS unless you have 9 or more virtual CPUs assigned to it. So what I like to do is to go in and I will assign the ability to extend vNUMA at 4 CPUs and up. And that's the command right there in the configuration parameters. SQL Server is extremely NUMA aware, and it actually goes way out of its way to balance NUMA nodes properly. So I like to go through and set that properly. Now, when it comes to CPU, DBAs are going to ask for as many CPUs as they can possibly get. The biggest thing is you have to show them it's not necessarily the number of CPUs that matter, because if they get what they want, they're going to stick with the physical machine sightings, and that may be too much. You all know you assign too many CPUs to a VM, it's going to slow it down just because of the wait times. Showing this to a DBA rather than telling them this, and you can do this with a pre-production machine. They can run some of their tests. You go and add the core count to whatever they want, and you go have them rerun their test. It might be slower. It might be faster. it just depends on the workload and how active things are. But I've actually doubled the performance of a SQL server going from 32 to 4 CPUs. It's very, very substantial there. Now, CPU count, got to right, I call it right sizing. It's the count that matters, but it's also the NUMA configuration. Now, one little word, CPU hot add does vNUMA across the board. A lot of people will recommend CPU and memory hot add. I generally don't want that with my SQL servers. I would rather use NUMA to my advantage year-round than, maybe have to take a outage during the maintenance window to add more. Your mileage may vary there. If you're e-commerce and you need burst capacity, by all means enable it. But most of the time, I'm okay without it. Okay, fun little comment here. I've had a lot of third-party vendors go, I have to have 32 CPUs in order for this 2 megabyte app to run, and just ignore them. Or, if they require it and they won't certify the app, placate them until the app is up and running, and then set it to what you really need it to be. Just do what's best for your environment, not necessarily what's best for the vendor. Okay, we'll skip that one. Okay. Broken animation there. Sweet. So when I say CPU count matters, it's not just a CPU count, but it really is vNUMA. And to show you how much vNUMA really does matter, at a customer site a while back, we went and did a set of tests. We had one 16 vCPU SQL Server VM. I wanted to know what's faster, 16 CPUs in a 4-socket by 4-core configuration, or 2-socket by 8-core configuration, or 8 by 2. And this is a 10-core by 4-socket physical machine. We ran a synthetic workload, and we actually showed that the 4 by 4 was up to 31% faster, just because of the way SQL Server manages NUMA properly and how from VMware handles all of that. It's pretty scary. And then we went in and we did a lot of other digging, and we found that, yeah, it was actually solid when we extended vNUMA down to just 4 CPUs, so 2 virtual sockets by 2 virtual cores. And again, 20, 30% performance improvement, no code changes. You will be the hero of your data team if you can get that kind of a performance improvement without any changes, any code changes. It's huge. And the cool thing is, in a dev environment, they have the ability to go run, this was done with HammerDB, just in free open source database load utility. They're bound to have long-running processes with database backups that they can replicate. However you want to do it, they can do those. It's pretty substantial. Cool. Any questions on CPUs so far?
Not on CPU. Yes, actually there are, now that I look. I'm going to circle back around to that 128 gigs of memory license, and I think we're talking back to the standard question where it's limited to 128 gigs. So if you have a standard license, you give SQL that 128 gigs, and then is that license for that and then extra for the OS, or is that for the whole VM? Do you know how that works?
Yeah, that is per SQL Server instance. So what you would do, if you need to use all 128, I would give the VM 140 or 136, whatever you would need in order to go maximize the headroom for Windows and SQL Server memory management. Now, if you need to use more than that and you're limited to that one license, that would be the case where you could go and do 2 SQL Server instances on there, each with 128 gigs of RAM allocated. Again, as long as you have that allocated to the VM.
Yeah, I think that answers that question. It answers it for me. It makes it a little more clear for me. And somebody asked a question, actually, that I was very curious about. vNUMA aside, and it kind of goes outside the scope of SQL, but just a VM alone, will it make a performance difference if you take an identical VM with 4 single cores versus 1 quad core? I'm sorry, 4 single cores, so 4 sockets versus one socket, 4 cores. Do you know if that makes a difference at all?
You know, it's really app specific there. If the applications that you're running have done a good job optimizing the code for NUMA awareness, if you have NUMA extended down to the 4, I would say you would get at least a measurable improvement. It may not be noticeable, but I would say you would be able to measure an improvement. Again, it's very workload specific there, but I know SQL Server, Oracle, they're very NUMA sensitive, and you will get an improvement there, usually.
Sounds good. I've had arguments with a coworker about this particular topic, and I think it's settled, and I think I won, so thank you for that.
You're welcome. The fun part is prove it to yourself. That's the fun part, because all of these numbers, they stop any of the arguments. You know, HammerDB, SQLIO, iPerf, all these utilities, it didn't take 2 hours to run all of these tests to generate all of these numbers. That's the beauty of it. I mean, it was longer to reboot the host at one point than it was to run half the tests. Yeah, that's the fun part. It's all workload specific, but you know, it's quick, easy turnaround. It's a lot of fun being right with this stuff. Cool. Okay, so for memory, so we talked about CPU. Memory, it's a lot more straightforward. Now again, you know, DBAs are going to ask for as much memory as they can get. I like to say, you know, give the DBAs what's actually needed, because it does help, and it is cheaper than a faster SAN. But you gotta weigh that. You don't want to go overboard with it. You can actually ask the DBA these things: page life expectancy. What that is a value inside SQL Server at the instance level of a measure of how long SQL Server is generally holding on to memory before things start to get flushed out. It's measured in seconds. Now, if their SQL Server is down to 8 or 10, that's bad. That means, you know, I had one 2 weeks ago. SQL Server with 32 gigs of RAM had a page life expectancy of 8 seconds. That thing was thrashing storage like no other. They went and got a physical machine that they had lying around. We put a hypervisor on there and bumped the VM up to, 256 gigs of RAM. I/O went down by an order of magnitude because they were actually able to buffer all the stuff that they wanted. The page life expectancy was at that point measured in days and not seconds. Big difference. The other thing is buffer cache hit ratio, and this will give you an example and some numbers around how often it's actually having to go to disk. Now again, the lower these numbers, the more memory pressure you have, and at that point you've got numbers that can help you. You know, is P low? Is buffer cache hit ratio low? Is my I/O on this machine just constantly pounding this in? I'd say it's a good candidate for more memory. Okay. Any questions on CPU memory before we hit the storage topic?
Nope, that was it. Just some thanks for hitting some troubleshooting points that people have had.
Oh, no problem. I mean, like I said, I walk both of these worlds, and these are the things that I wish people didn't have to bring me in to go fix all the time. It's just, you know, one side doesn't know the nuances of the other, and it's hard to meet in the middle when you don't speak the same language. Okay, storage. This is, like I said before, the single biggest pain point of a virtualized SQL Server. And as with the others, the DBA is going to ask for as much storage as they can get. Okay, this is one of the resources where if they're asking for a terabyte, it's not because they want 900 gigs to play with. It's because they have data volumes that are growing at a very, very rapid rate. I mean, you've seen all the news and the write-ups. Data volumes are growing ridiculously year after year after year. Pay attention to their demands. Get them to show you the growth rate, and you can actually use that to predict. You know, it's like, yeah, they really do need that space. They are actively using it, you know, because nobody ever goes and deletes stuff. You know that, especially out of business-critical databases. So plan ahead, get them the space that they need, but it's got to be sized for storage performance and not just capacity. Now here's a big one. VMDKs, virtual disks, not RDMs. I use virtual disks anywhere and everywhere I can. The only reason for me to use RDMs was if on older versions of VMware, when I had to get around the 2 terabyte VMDK limit, which isn't there anymore, or if I was doing traditional SQL Server clusters with shared storage for storage failover capacity, or for SQL Server high availability. That's the only time now that I will recommend an RDM, and it's because you have to, not necessarily because I want to. RDMs functionally give you the equivalent performance of a VMDK. They're not necessarily noticeably faster. I use VMDKs across the board. You get all the flexibility and the bells and whistles of a hypervisor, and you're not limited to VMs that can't move, especially with SQL Server clustering. Now, we talked about this before. If you're on production, I generally will do thick provisioning or zeroed. If you're on a flash array, I will still do that, get rid of that zero write or the penalty on there. I talked about it before, PV-SCSI, 64K NTFS block size. Now, SQL Server does, in fact, need free space to operate efficiently. And I say that liberally, because if I'm doing data loads in the evening, my transaction logs can grow. My tempdb files can grow if I'm doing heavy sorts or heavy, really heavy processing. Or if I'm doing things like rebuilding indexes, it's going to use free data file space to actually go do this, and then it swaps the good one with the old one. I generally say 20% disk free per drive. Now again, it adds up, but SQL Server does need that to be healthy. And you can measure this. You can watch the free space counters inside Windows, and they go up and down. They don't just go down. Then the last thing here, I will format all my disks inside Windows as GPT disks, not MBR, just so they're easier to resize once you hit 2 terabytes and above. This is how I lay out my virtual disks. Operating system, I do my SQL Server installation. I call it the instance home. System databases, user database data files, 1 or more virtual disks for those, depending on the load. Usually more if it's pretty heavy. 1 or more for my transaction logs, because again, it's a completely different kind of I/O pattern. I'll split those out. My tempdb, which is that dumping ground for all the temporary stuff. If I'm doing heavy SAN-to-SAN replication, and that's my DR strategy, I may actually move the Windows page file to a different disk, and I'll park that on a line that gets replicated far less frequently than the others. I will save all of that bandwidth. And then if you want to do local backups of SQL Server, I'll go put that onto another drive, and I can park that on a lower tier storage, things like that. Okay. Any questions on virtualization for the VM?
We do have a couple, yeah. One of the first ones was the VMDK versus RDMs. Does that include always-on clustering?
So there's 2 types of always-on there. There's what always-on is it's basically an updated form of database-level high availability for SQL Server, for those that haven't heard of that before. There are 2 ways to do it. One is where it basically extends a traditional cluster, where you do have the disk-based share that you have to worry about with traditional clustering. In that case, yeah, you do need RDMs, or using SMB3 to another VM. Or you can use always-on availability groups with independent copies of the data, and the data gets replicated under the covers. They're 2 distinct VMs. In that case, they're free to move around however you need, and I'll use VMDKs across the board. That's actually why I put the red asterisk right here next to the E drive, because if I'm doing heavy database replication under the covers, be it mirroring or availability group replication or even transaction log or data replication, those system databases get hit kind of heavy, and I may opt to put those on a faster tier of storage. So in that case, all VMDK, life is good. You get all the freedom and the flexibility to do whatever you want.
All right. Another one is there any benefit to breaking the page file from the OS disk if you're running tierless or hybrid storage?
Again, it would depend on how much your Windows OS is paging. I would say probably not very much benefit to that. Usually SQL Server, if it's sized properly with the right amount of memory, you're not paging that much, so the page file is fairly inactive. So in that case, you're probably fine to leave that. But again, profile what you've got and just see, is that thing getting actively slammed all the time? And in that case, do you want to break it up or not? It's really your preference there. How much load do you want to put in one spot or the other?
Sounds good. Another question was, I noticed you use a lot of drive ladders. What are your thoughts about using mount points, especially for automation and standardization?
No, it works great. The only trouble I have with mount points is not with the mount points themselves, but it's with monitoring tools that may not be able to handle mount points. Otherwise, yeah, by all means, use them.
Cool. Let's see. If you're moving to a single, if you're moving a single file database onto a multiple file database, would a SQL restore level the data over the multiple files? There, I burned through that one first try. Does that make sense?
Yeah. Boy, off the top of my head, I don't want to steer you in the wrong direction there. At the end of this, stay on. Let me get your contact information. I'm going to make a note of that right now, and I will get you an answer to that.
Good. Yeah, and they said, for instance, so a single MDF file to, for instance, 4 MDF files. Does it actually level that data?
I want to go test that before I give you an answer there.
Cool. I can get you. You might be able to see the questions. I'm not sure, but we can definitely follow up with those.
Sweet. Yeah, I'll get you the good answer there.
Perfect. Thank you.
Cool. Any other questions?
That was it for this round, it looks like.
Okay. So now, inside the virtual machine, and unfortunately this is about where your involvement as a VMware admin generally starts to kind of taper away. This is where most of the interaction with your team generally stops, but it doesn't have to. So you can work with them at the SQL Server instance, at the database level, and at the application level, and give them the things that you want them to do to actually go through and do stuff to make your life easier. So again, the overall goal, stopping resource contention while maintaining performance. They can turn on backup compression. You get maybe 5–6% bump in CPU utilization, and you're writing half of the data across the network. Substantial. They can use large memory pages. Cuts down on memory thrashing, cuts down on CPU consumption, gets a little bit faster. Now, there's these two settings inside SQL Server here that I'm going to highlight. They're called max degree of parallelism, max DOP, and cost threshold for parallelism. It basically says, hey, SQL Server, at this arbitrarily computed value of parallelism for something that's doing inside there, I want you to set a threshold that says you can actively parallelize anything that is above this threshold, but don't do it for some of these other low-hanging fruit. It's very workload specific, but I have found that it's actually faster on some workloads to increase that threshold to say, hey, SQL Server, don't parallelize more of your work. And with the max degree of parallelism, if you're going to parallelize it, use less CPUs to parallelize it in. And the resource scheduling overhead of an actively used SQL Server was actually used to our advantage because we cut down the amount of tasks being distributed across multiple CPUs and multiple NUMA nodes. And we actually got faster performance by telling it to use less resources. It was faster on some of these to just plow through a query with a single thread than it was to try to parallelize it wait through all the CPU queues for every CPU thread, have it all come together at the end, and then return. It sounds weird, and it's one of those things you got to play with it. You can work with them, and you can actually see this inside vCenter. You can see what these CPU stats are. But it's one of those settings by workload. They can actually go tune these, and you can actively judge and see what it's actually doing to the performance. So the add more memory thing has been here for a while. SQL Server does use it. Now, one of the questions I know that was asked coming into the session was, what about server-side SSD caching? Believe it or not, I love it. I love it, love it, love it. So vSphere Flash Recache, Fusion IO, Pernix Data, all of these caching technologies, I've had extremely good success with those. Because you know, SQL Server on average is on a normal OLTP workload, SQL Server is about 80 to 85% read, 15 to 20% write. If I can cache even a portion of those reads, that's substantial. So on an OLTP workload, I've averaged about a 35 to 40% overall performance improvement in that SQL Server on a day-to-day standpoint by doing VMDK read caching. That's not even to say write caching with some of these newer technologies out there. Very, very substantial, and again, a lot cheaper than a new SAN. And then the cool thing is, because it's per VMDK, now I can go pick the hotspots that will benefit from it, but I'm not going to waste it on stuff that might just be sitting there and stale and very infrequently used. It's kind of fun. So work with the DBA and say, hey, these are the things available to me as a VM admin. Let's work with you. You go tune stuff on your side to reduce resources. Tune stuff over here. We're going to meet in the middle, and let's see what kind of performance improvement we can make. Remember, change one thing at a time, test, and that way you can actually start to see what actually is making the improvement there. So again, at the database level, the goal is reduce the resource queue contention. So I talked about spreading out the workload before. A lot of this stuff is stuff that you have a harder time getting access to. I mean, this is the stuff that will make or break the performance. Better database table design is something that you really can't get into easily. Most of the time, the databases are not designed very well. They're not that efficient. Indexing strategies is huge. You can do indexes inside SQL Server that say, use less data on disk and use less memory and CPU to figure out where we need to go to get all this data to fulfill a request. Transparent to the application code. So that's one of those techniques that I can go and do a lot with. Enterprise Edition gets you table and index compression. So again, less I/O, and it actually compresses it in memory too, so you can get more data in RAM. It's Enterprise Edition, but they can turn that on fairly easily. And again, that one's transparent to the app as well. And then there's some new versions of SQL Server that have gotten really, really aggressive with in-memory constructs. I don't know if you've all heard the term hackathon. They call it now in-memory OLTP, came with SQL Server 2014. It allows you to do in-memory objects and data processing all in RAM. That you can persist the changes to disk if you want. But it's very, very fast for, honestly, the few niche cases that are out there for it. It's very, very powerful, but it's got to be the right tool for the job. I've also done a lot of work with something called updatable column store indexes, which are ways to and make some reporting processes a lot quicker. But again, you shift that bottleneck from storage onto CPU and memory. They're faster. It's still a bottleneck. And then application data handling is another one. But it's hard because these are all things that are very, very hard for infrastructure guys and sometimes even DBAs. It's hard for them to control. I mean, third-party vendors, I have seen some of the worst code come from third-party vendors. They maybe want to pull my hair out. Some of the code is just horrible. And a lot of them, you try to submit a fix, and they get mad and they say, we won't support the application because you're changing our code, even though one database index is the difference between a 4-hour runtime and a 10-second runtime. It's substantial. It's maddening. Things you can't control, data volume. data growth rates. I mean, that's just the nature of a business or an application. Transactional volume, bad design, bad code, legacy apps, people. People is one where you may not be able to control them, but with enough education, you can start to make a difference. And that's why I've got these last couple of slides in here. Virtualization in the DBA, how to really talk to the DBAs. I mean, the nature of what a DBA does is very stressful. I mean, we are under a tremendous amount of stress to maintain the data and protect the integrity of the environment that we have the control over. Because if a database goes down, businesses can fail, period. If the infrastructure that the database is running on, the business can fail. So because of that, we are very, very, very fearful of disruptive change. Now, if you've watched data technologies versus infrastructure technologies versus app technologies, you'll see front-end applications, they are rewritten in different languages. I mean, it's like a flavor of the week thing. But infrastructure moves a little slower. Data technologies move a lot slower. That's for that reason. It's a big, big change. And the scary part is most DBAs don't have any experience with hardware or virtualization or even at the OS. So they fear that black box. So now what can you do? You need to involve them. Be transparent with the environment. I mean, virtualization tears down organizational silos. It really will open things up where, whereas before the DBA may have owned the stack and they were in control of it all, and now you've got networking, storage, VM, system, plus DBA all working together because it's all so interrelated. The thing that I love to say, and a lot of folks here are probably going to yell at me, I say give not just the DBAs but any app owner read-only access to vCenter and let them see the performance stats of the VMs that they manage. Work with them so they understand what they're seeing, and I promise you that little bit of education, what is virtualization? And if you have any DBAs in your environment, just send them over to my website. I've got like 9 or 10 different training videos. It's virtualization for DBAs, guaranteed to help them understand what is virtualization and how can they use it. And if you get rid of that fear, and if you guys start involving them more into the process of managing their environment from your perspective, life gets better for everybody. They're going to become your friends and not the people that you all curse. It really, really will just make or break an environment. So anybody have any questions? There's a good book here from Michael Webster. It's a really good book for VM admins. It gives you a lot of the talking points for how to go talk to the DBAs, how to help them troubleshoot and identify and benchmark and baseline, and how you can meet in the middle there. It's a really good book. It's available at Amazon. Just came out. Any questions? I mean, we covered a lot of information.
We did, yeah. There's a couple others. Somebody followed up on the normalizing question. They said there's a SQL Server trace flag that you can set that will auto-grow. You can set the level against all your MDF and NDF sets. It's a server-level setting, if they understood the question correctly, which it sounds like they did. So it sounds like they're...
I think that's trace flag 1117, if I'm not mistaken. What that is that will make all the data files auto-grow at the same rate. I thought the question was, if I have a single database file backup and I want to restore that, can I restore that into multiple data files? Was that accurate? Because that's what I'm going to research.
I'm going to scroll. Let's see. Oh, hang on one sec. Oh, if it says if you are moving a single file database onto a multiple file database. So I think the assumption is that you can. And the question was, would SQL restore level the data over the multiple files?
Yeah, and that was the restore part there. And that's why I want to go research that. I think you can, but I want to get the syntax for you on that right.
Okay. Let's see. Another question was to normalization of data. Should you do a full normalization of the data? Would that slow things down with too many indices?
Well, I mean, again, that's very workload specific. I will say too many indexes, if they're all actively being used, may be a good thing, but most of the time, indexes can go unused. And in fact, there's a set of diagnostic scripts by a gentleman, a good friend of mine by the name of Glenn Berry. If you go to SQLskills.com, he's got a blog there, and he actually lists these diagnostic queries for free out to the world. In that script are two pieces. One is it's a little query that will tell you what indexes are not being used. And you can actually go see if your index strategy is working appropriately. The other one in there is, do I have any missing indexes? So if your indexes are properly being used and all of them are active, I would say you're good. As for the normalization part of it, it really is app specific and dependent. I'm all for normalization until you're joining 22 tables to get one line that's commonly accessed in your app. You know, there's a balancing act there.
Perfect. There was, oh wait, actually that might have been it. I think that was all. There was just a comment about all you can ever do in IT is move the bottleneck around. So there's always a bottleneck somewhere, but just try to shuffle it out of your realm, I think, is the the way to go.
That's really, you know, I hate to say it, but that is the bottom line. It's shift the bottleneck out of the infrastructure and into the data processing and handling. If you can do that, you're going to watch your CPU consumption go up, but you're going to watch everything get better. And if you can shift it to the point where it's now on the application owner's desk and not yours, you just took care of setting up the framework for them to actually be able to go tune their code and have it actually work. Because if the infrastructure underneath one of these systems is crap, I don't care how much tuning you do, garbage is garbage and it's going to run really, really bad. If you set that framework up properly, you'll help these apps fly. And the more improvement they make to their code, the better it's going to get.
That makes sense. I don't see any more questions here. So that's all for questions. Do you have any closing?
Well, I mean, thank you all for sticking around. I know this is a long session. I do a tremendous amount of speaking on behalf of DBAs to VM admins. You know, these are the biggest systems that you're going to virtualize. You can do it successfully. It just takes some TLC. So for those of you that are going out to VMworld next week, if you go to the expo hall, I will be hanging around the Agile Systems booth. Feel free, come up, say hi. We'll go get a drink or some food or something. I'd love to meet up with you all. So thank you all for attending. I know this ran a little late, but I really do appreciate you all coming.
Cool. Yeah, there's a lot of thank yous coming in the questions box too. So thank you very much. I know I learned a ton about stuff that I never knew I needed to know.
Awesome.
So I just have a few closing remarks before we close this out. Remember, next week the U.S. and EMEA brown bags are off. Don't expect to join a webinar and see us. However, we are streaming the Tech Talks from VMworld on Saturday. And if you are at VMworld, on Sunday, and if you're at VMworld on Sunday, check out the opening acts, and maybe we'll see you at the VM Underground. I think there's still tickets left. I think they're like $10. You can get them online from Eventbrite. Maybe we'll see you there. And this will be uploaded to professionalvmware.com. In the near future, we're pretty busy with getting ready for VMworld, so it may be delayed a little bit. I know last week's Exchange Talk isn't up there yet. So thanks, everybody, for joining. And you can, I'll give you a second to take down his contact info, and we will see you in the future.
Awesome. Thanks, everybody. You guys have a good night.
Thank you.